Hi, welcome to another important lecture of mechanics of machines. So today the topic of discussion is constrained motion and kinematic pair. A motion is called constrained motion if, irrespective of the direction of applied force, the motion occurs in one direction. And basically there are three types of constrained motion, which are: number one, completely constrained; second one is the incompletely constrained; and the third one is successfully constrained motion. In the next slides we will be discussing each one of the item in detail with the help of animation. A motion is called completely constrained motion if the motion between two links is constrained in one direction, and this one direction motion is not dependent on the externally applied force. Before proceed to the animation, just I want to say a few words about the constraint. The word constraint means limited or restricted or confined. So you can Google this word, the constraint, and you will get some other synonyms as well. So basically, the word constraint, it's all revolve around the limiting something. So in case of a completely constrained motion, as you will see in animation, let's start the animation and then we can discuss it. So what is happening? A rectangular bar is sliding inside a box which has a cubical cavity. So what is happening that this rectangular ball can only move in one direction, and the one direction motion is this one. So this bar cannot move in other direction like this direction, the y direction, or it cannot rotate around its axis. The only movement it has is in one direction, which is in this direction. Again, the only motion is in this direction, no other motion. That's why this type of motion is called completely constrained motion. So second type of motion that we are going to discuss is the incompletely constrained motion. Why it's called incompletely constrained motion? Because there is more than one type of motion between the links, and the motion is dependent on the direction of externally applied forces. So I will repeat it again. In case of incompletely constrained, the motion between the two links, as you can see here, the box is one link with the circular cavity, and there is a rod, the circular rod with the flange at one side. So as you will see in this animation, what is going to happen, the circular rod, basically it is moving inside, and also it is revolving around its axis. So there are two types of motion. Number one, the circular bar is moving to and fro inside the inside the box, and also it is revolving around its axis. So this type of motion, when there are two links 1 and 2, link number 1 is the circular rod with the flange, and the link number 2 is the box with the circular cavity. So in this type of two link mechanism, their motion is in more than one direction, means that this circular rod is moving to and fro, and also it's revolving around its own axis. So the last example of constrained motion is successfully constrained motion. So before proceeding into this type of constrained motion, you have to recall the previous two types. The first one was the completely constrained motion, where you have observed two links. One was the box with the rectangular cavity inside, and the other was a rectangular rod which are moving in axial direction. So in the case of completely constrained motion, the motion was only in one direction. So in case of the second example, the incompletely constrained motion, where the motion was the bidirectional, in the incompletely constrained motion, we have a box with the circular cavity. In the circular cavity, there was a movement of a rod with a flange at one side, and there was two motions. One was the axial and the other was the rotational motion. So we are taking the same example of the last slide, which was the incompletely constrained motion, and we are trying to convert this incompletely constrained motion to the completely constrained motion. I will repeat it again. We will try to convert the incompletely constrained motion to the completely constrained motion, and this conversion is called successfully constrained motion. How we can achieve it? We will just install another component in the assembly, and by installation of the external component in the assembly, we will retain one of the motion of a link. So let's see the example of successfully constrained motion. There are two links. One is the box with the green color, it has a circular cavity inside it, and the other is the rod, the pink color rod with a flange mounted at one side. So the only difference between the previous slide and this slide is there is a golden color ring which is mounted on the assembly number 1 or the link number 1. So the link number 1 is assembled with this golden ring, and by this golden ring we are fixing, or we are making constrained motion. So motion of this pink rod with the flange will be constrained in only one direction. So in the previous slide, this rod with the pink flange can move in axial direction, and also it can rotate around its own axis. Let's see in this example, by installation of this golden ring, how we can fix or we can constrain the motion of this rod with a flange. You can see it now. The flange with the rod only rotates, so there is no more axial motion. So by installation of an external component to the link, we can constrain the motion. So this is an example of successfully constrained motion, in which we converted the incompletely constrained motion to the completely constrained motion. I hope you understand this concept. If you have some issue with it, or you have some question or queries, then please let me know. You can ask a question by Google Classroom or WhatsApp group, whatever is convenient to you. So let's move to another part of this lecture, which is the kinematic pair. So kinematic pair is formed by joining at least two or more links. Whenever you join two or more links, the ultimate result will be a kinematic pair. So kinematic is derived from the kinematics, which is related to motion. So whenever you combine two or more links, then they will have some kind of motion So whenever there is a motion, so we call this pair of links as a kinematic pair. So as usual, similar to the constraint motion, there is a classification of kinematic pair as well. So according to, they are classified according to type of relative motion, the type of contact, and the type of mechanical constraint. So let's discuss one by one. So what means by relative motion, then contact, and then mechanical constraint. So according to the relative motion, there are five possibilities then that links can have a relative motion with each other. The first one may be the sliding, the second is the turning, rolling, spherical, and screw pair. So the links, two or more links, they are called pairs. So they have a relative motion according to five different types. So we will in the next slides we will discuss each one individually. So stay tuned to this lecture and please pay attention. Um, so the first type is the sliding pair. The classical example you already know. I have shown you the video where there are two links. One link is the box with the rectangular cavity inside it, and the other link is the bar which move inside the rectangular cavity. So the only motion, the only possible motion is the sliding motion. So this rectangular bar, it slides inside this rectangular cavity. The second relative motion of the links, the possibility is the turning one. You already have seen the video where there are two links. The box link, which is the green color, it has a circular cavity inside it, and there is a another link which is a rod with a flange mounted at one end. So this link can rotate inside the green box. So it's a classical example of turning pair. The third one is the rolling pair, where two links, the roller and the flat surface, they have a relative motion, or they call it rolling motion. You already known to this type of motion when you are preparing your breakfast, lunch, or dinner, especially in case of COVID-19 scenario. Most of you guys may help your parents or siblings in preparing the breakfast, lunch, or dinner. So maybe you're known to this activity where you make a chapati, paratha, or something else by the help of a roller. So this rolling motion in the axial direction, and also there is a rotational one, is the classical example of rolling pair. The fourth one, the spherical, where a sphere, just like a ball, is moving inside another link which is a cup type. So there is a ball and a cup movement. So the only motion, the possible motion, is the spherical motion or spherical pair. So this is a classical example of spherical pair. The last one is the screw one. So screw pair, there is a rotational plus axial motion, but both the motions are in specific path which is called the helix. So the motion, the relative motion between the screw pair, so in this case there is a nut which is called one link, the other link is the screw link. So there are two links, one link is a nut and other is the screw. So the relative motion between the two is the translatory plus rotation, but rotation is not simple as around the fixed path. Rather, the path is the helical path, and the path is always changing around the x-axis or the axial direction. So that's all for the relative motion. Let's move to the second part where the classification is according to type of contact. So there are two type of contacts in case of kinematic pair. Number one is the lower pair or surface contact. The second one is the higher pair or point or line contact. So again, the classical example of lower pair or surface pair is one where there are two links, the box and the rod, and the motion or relative motion with respect to each other where they have a surface contact. So as you can see, if this rod move inside the cavity of this box, all the surfaces 1, 2, the other 3 and the bottom 4th, so all the 4 surfaces make contact with the 4 inner surface of this cavity. So there is surface contact. The second example is of the second type, the higher pair, has two classical examples, the point and the line contact. In case of point contact, the things are very simple. A spherical ball is rolling over any kind of surface. So when spherical ball touches the surface, any type of surface, the contact will be a single point contact. Whereas a roller over a flat surface is a classical example of a line contact. So by this means the type of contact the discussion about the type of contact is finished. So there are two types, lower and higher pair. Lower pair is also called surface contact, or higher pair is also called point or line contact. Let's move to the third category. So here's the final type of classification of kinematic pair, which is according to mechanical constraint. So there are two types of mechanical constraint. One is the closed pair, other is the unclosed pair. I will request you to please pay a little attention more here because the things is simple but it's difficult to explain it. So I just request you to please pay a little attention here just for a couple of minutes and then it will be over. So what is happening here, there are two links. One link, link number 2, both are the hollow rods. They are fixed by a pin or they are joined together by a pin. So link number 1 is joined by link number 2 with the help of pin. Once both the links are joined together, then we don't need any external force to further joining them. Means to say that once they are fixed by this pin, both the link 1 and 2 are fixed by the pin, then there is no need of external force to fix or constrain both the links together. This example will be further clarified. I will move if I move to the unclosed pair. So in case of unclosed pair, the classical example is a cam and follower. The follower is also called pinion. So there are two terminologies used for the follower or pinion. So both are the same things. What is happening that this follower is pushed by this spring so that this follower is making contact with this cam. So here is the cam, here is the follower. Follower is pushed by this spring so as they both the follower and the cam make contact with each other. If this follower is not here, then the contact between this follower and the cam will not be there. I will repeat again. This follower is pushed by this spring so that this follower make contact with this cam. if there is no spring, then the follower will not contact with this cam. So there will be no contact if there is no spring. So spring is pushing it, so this spring is the external force, and by help of external force, link number 1, which is the follower, is making contact with the link number 2 cam. So this is called unclosed pair. In case of unclosed pair, we always need a force for contact between link 1 and link 2, where in case of closed pair we don't need any type of external force to have a contact of link 1 to link 2, because they are already fixed together or constrained together with the help of pin. Once they are fixed, we do not need any spring or external force to make contact like link 1 or link 2 with each other, because they are already contacted by the help of this pin. So that's all from this lecture. If you have any question or queries, please let me know, and I will try to address your queries as soon as possible. Stay safe. Bye bye.